So hi, I'm going to be talking about tool calls and agentic AI systems. Now, if you're seeing most of the software applications that have been built in the last 3 to 4 decades have functions, have behaviors that generally get invoked based on certain events. And in the procedural world, the degree of calling the function based on an event is a more deterministic way of doing things. But now we are entering into the agentic AI world where the non-determinism in the LLMs of the agent may result in issues when the tool calls don't really happen or they don't go as planned. So agents, most of the agents today, the frameworks generally have a tool call functionality that support core functions and they need to be invoked at the right time. Now, if this is totally autonomous, now if you're really not building sequential agentic system where you decide as to when the tool has to be called and you leave that responsibility for the LLMs to decide as to when to call the tool. Now, with the non-deterministic behavior LLM, there is a chance that the tool call at times, certain percentage may not go as planned or the parameters may be wrong, or the function name can be wrong. Now, this is largely attributed to the hallucination side of the LLMs, and tool calls generally do go wrong. But now the risk involved in tool calls going wrong is pretty high. Typically, let's say for example, if you've written a withdrawal agent and there's a withdrawal method and the withdrawal method doesn't really go as planned, that means there's a risk. Okay. Now, how do we, that's just, that's a very simple example to state now, but how do we really take care of the hallucination side of the tool calls? Now, two methods. I'm just going to be, there are multiple methods in order to do that, but I'm just kind of broadly kind of covering two specific methods, which we've been dealing and we've been, using within our systems. Now, one is basically you fine tune to handle tool calls better. So that's a MatchTIR framework we're talking. And second is basically, in situations where you want to handle the tool calls post LLM calls identification, we intercept the messaging of the agents and put that through a classifier, which uses own internal representation to decide if the tool call is valid or not. At a very simplistic level, this is the classifier, which takes all the message, and if there's a tool called instead of the message, it basically tries to identify if it tries to classify if the tool call is valid or not. It's a very simple thing. It's an MLP. You can take in the basic MLP network to basically kind of train that out with certain data, and that should kind of do the job. Now, kind of getting into MatchTIR. Now, MatchTIR basically fine tuning for tool use. Typically, here you end up taking a pre-trained model. The fine tuning process involves a golden standard tool call. So you basically will need to have a sample data set which talks of the golden standard tool calls and in terms of what are the tools to be called and what scenarios. And then you take the predicted tool calls outcomes, as an input data. And that's your sample task and scenarios. Now you then end up doing a bipartite matching and scoring. May sound too complicated, it's very simple. It's not, it basically just compares across golden standard and tool calls and predefined tool calls and they come out with similarity score in terms of the match is high score or a mismatch low. Now, if it's high, then you basically put a penalty in terms of is it being applied, and then it's that kind of basically the reward optimization. Some level of reinforcement learning is kind of pushed back into the entire system to fine tune the LLM to kind of get to the point where the accuracy of tool call becomes a lot more higher. Now, you can definitely use this, but then this ideally means that you need a data set and you obviously need to fine tune and tool calls don't change that often. So in case you do add a new tool call, you will need to do some level of fine tuning again as well. So this is one method that we've seen which is good in case you have too many tool calls and you really want to kind of keep everything at the LLM level and not really deal with the situation a post LLM call. Second is now we kind of get into a classifier-based tool called validation pipeline. Now, this is basically, I talked about the multi-layer perceptron, network. We end up, neural network we basically end up using. We train it with specific data to identify true and false. And in this case, yes, every message which gets generated by the LLM is actually pushed through this interception layer and the classifier then basically checks basically, if the true call is true or false. If it's true, then basically executes the tools, and if not, then basically you can then kind of find ways to correct and then try to recall the tool differently. Now, this is a post factor method. The earlier one was more of a pre-factor. Now, it really depends in terms of which one you would want to use when. The point is, in case you have too many tool calls and you really don't want to be dealing with the overhead of basically intercepting the message of the agents after the LLM call, then you're probably better off with using just the the fine-tuned model to do this, to do so. And in case you don't want to deal with the fine tuning and the GPU compute, etc., then you could end up using the interception or the the classifier in terms of basically to see as to where this is really going. Now, having said again, both has pros and cons. There's a little bit on overhead with the MLP. The overhead is very limited. It is there, but it's not really heavy. It's an additional an instruction we call at the at intercepting from a message standpoint of it. There will be some degree of slowness, but it's not something which is visible or or which is really accountable to the overall process of the agentic conversation. There will be a mild thing. But having said that, the second method is a lot more easier to implement. The first one is more expensive from a GPU and a one-time hallucination check standpoint of view. That means your base model. I said. Now, in case you're not using your own LLM, then obviously then you could just go with the second method, and that kind of helps a lot. Now, with that being said, any questions, comments, feel free to kind of come back to me. Thank you for this session.